G'day everyone, we're back here with another related rates question. In the previous video I said that one of the styles is the oil slick style, adding volume to it, seeing what happens with the side. This one right here is a very similar question. It's another type of question that uses related rates, or a style of related rates. So this is the classic question where you have a lamppost of some height, and a person is either walking towards or away, it can be both ways, from the lamppost. And you can see this dashed line, it doesn't quite get past the head there, but this dashed line is showing you where the edge of the shadow would be. So as best as I can draw, the shadow would kind of look something like, something like that, of the shadow of the person in front of them as they walk along. Think about this in practice. When you're standing very close to the lamppost, your shadow length is very small. Now if you walk at a constant pace, 2 meters per second, the length of your shadow increases quicker than the pace that you're walking at. Now I've just noticed a small mistake here that I did. I wrote shadow length there, I didn't mean that. I meant shadow length there. So the shadow length is this length here. It's only in front of you, because there'd be no shadow behind you, because the light would only spill this way. All of the light would be on your back. The front of you wouldn't have much light as you walk that way, the shadow being in front. So understand this diagram. This diagram is important for you to understand and see what is happening. If you don't understand this diagram or what it's telling you, then when you get a question that's all worded, you won't be able to put it in this style and see straight away what you're doing. Please draw a diagram. Get a worded one, draw a diagram. Even if it's just a bit of a sketch, it will help you to see what is going on. There's a couple of variations with these as to whether the person is walking in this direction or walking in that direction. Okay? So there are some variations, and you make a few alterations to where you put your X's, Y's, Z's. Okay? So make sure you see each style in this style. Okay? So here's our information. You can see the height of the person, see the height of the lamppost, see the speed they're walking, see where the shadow length is. The question here is asking, what is the speed of the increase in their shadow? Okay, so how quickly is their shadow length increasing? Now, because I've called their shadow Y, that means I really want to find dy dt, don't I? The length of shadow increase with respect to time. So this is the thing that I want the rate of. But I don't even start there. I don't start there with related rates or chain rule. I start with similar triangles. Similar triangles are what I've got to see, because at any snapshot in time here, the triangle that is formed by Ned here, in this triangle right here, is a similar triangle to the one that the lamppost forms. So I've got similar triangles. And that's why I'm writing it up like this with X and Y. So you can see 4.5 over 1.5 is these two, bigger to smaller. So therefore, X plus Y over Y is the bigger, both of them, divided by the smaller. So this is really just similar triangles, right? And if you were to know Y or X, you'd be able to figure the other ones out. But even if you knew Y or X, you wouldn't substitute, because you're not asking for the distances, you want the rates. So never think I'm going to substitute into there. That's not where you go. A little bit of rearrangement here. You can see what we've done. One on one side, play around, get down to here. Y in terms of X. That's where we want to get to. Now that we're there, we need to somehow turn this into getting this. Now we've only got X and Y here. Only X and Y. So here's the trick. If I put it over here and go Y equals X, and I'll put it times a half. That's the same. Now here's the trick. Remember that when we integrate things, we're really integrating both sides. When we're multiplying both sides, when we're dividing both sides. Well here, what I'm going to do is I'm going to write dt, and I'm going to write dt. So effectively what I'm doing, I haven't finished yet, is I'm applying the derivative with respect to t. So I'm kind of doing, let me put it in a different way, I'm really doing d dt, and I'm squeezing in here d dt. But because I'm doing the same to both sides, I don't need to do anything. And secondly, the derivative of something with respect to time, when I'm talking about x, is just itself. I can't differentiate x with respect to time. So all I do is this just ends up being d dt. Because I don't need to differentiate the x. I can't differentiate the x. And same dy dt. So I kind of just throw on d dt on both sides, but the reason is that I can't differentiate the x or y with respect to time. They're effectively just constant. Leave them the same. So then once I've got that, I can recognise that this right here, that is the speed that the person is walking. So that's dy dt. So dy dt here is actually equal to 2 equals dx dt. Oh, I think I've got this the right way. No, I've got the wrong way around. No, start again. This is the speed the person is walking, so that's dx dt, the rate of change of x with relation to time. So dx dt here is equal to 2, meaning that I can work out dy dt equaling, well, you can do that, 1. And because the whole thing was in meters per second, this is just 1 meter per second. So at this particular point, the speed of the shadow increasing is 1 meter per second. Okay? But I guarantee you, if we were to move this forward, you can see that the angle of this line would splay out this way, and the speed of increase would be much, much more. So this formula is the thing that's governing the link between x and y right at this point. But if we move this along, change the angle, get things sorted differently, this will change, meaning that this will also change. So you see that link between all the things going on. Rearrange, get a formula, throw in to get it to the way that you want, get some numbers in, answer comes out. They'll usually come out to easy numbers. If you get crazy numbers coming through, stop, you've done something wrong. Just as I say, there's 2 or 3 varieties of this sort of question, so make sure you see them. The other one that comes up commonly is a rotating beacon. Okay, then you've got to bring in your radians so that you've got the beacon rotating. It'll be in terms of theta, and you think about a rotating beacon and the light shining against a wall. When it's way over here, it's moving fairly slowly, and then it whips quickly past, and then fairly slowly. So the lighthouse type question. That's the other one. I'll try and do a video on that sometime as well. Thanks guys, see you later.